Oops. What just happened? There we go. After the first insertion, okay, Turing is 1812. Darwin and Newton are what we expect. After the second, we've replaced the value. We don't get 2 entries for the key Turing. We only ever have 1. Okay? And that's how dictionaries work. In Python, in Perl, in Ruby, in Java, in C++, in C#, in every language you're going to ever hit except Fortran 77, there will be some way to create one of these. It might be called a map, an associative array, a hash, a dictionary, but it works the same way. Key-value pairs. Okay? The keys are all unique, and keys appear at most once. The key is either present or absent. If it's present, there's a value associated with it, or it's not there. But you can't have a key appearing 2 or more times. Okay? Well, this is kind of a useful thing. This is kind of a useful thing. Let's see how it can be useful. DNA equals GATTACA D TGCCA DDDTTGCA. How many A's are there? Yeah, right. Human beings shouldn't do this. They'll get it wrong and they'll get bored. Bored people are dangerous. Okay, so count equals an empty dictionary. Okay? And then for each character, I think they're actually called bases, aren't they, in DNA? For each base in DNA, okay. If base is a key in count, then add 1. Else, count of base equals 1. Print count. What am I doing? I'm going to count how many times each of those characters, I'm going to count how many times each of those bases, each of those characters appears in that string. With 5, 10, 15, 20, about 25, yeah, I could do it by hand. With 1,000,000, nice to have the program. Okay. The for loop is going to assign each character out of the string to base in turn. A for loop over a string gives you back the characters one at a time, just as a for loop over a list gives you back the list elements one at a time. For loops work on more than just lists in Python. Any kind of collection can be for'd. Okay? With a string, you just get the characters. With a list, you get the entries. With other structures, like dictionaries, you get something else that we'll look at in a moment. So I'm going to get G, then I'm going to get A, then I'm going to get T, then I'm going to get T again, and so forth. In says, is this thing a key in that dictionary? Is G in that dictionary? Well, initially, the dictionary is empty, so the answer is no. So we come down here and we say, good, give it the value 1. This is the first time we've seen it. So after we go through this once, count of key G will be 1, because we've seen 1 G. All right? Come around again. We've got an A. Is A a key in count? No. The only key in count is the letter G. So we come down here and we say count of letter A is assigned 1, because it's the first A we've seen. All right? Come around to do the T, and then we come around to do the second T. Okay? So our keys right now are G, A, and T, and we're on the second T. We say, is T a key in the dictionary? Yeah, it is. Okay. So somehow we have to change its value. We have to add 1 to the count of the number of things we've seen so far. Okay? And at the end, after we've done this, we've gone through the whole thing, we've added up how many of these we've seen, we're going to print out the dictionary, and that'll tell us how many of each letter did we see. It's exactly what you would do on paper. You're going through a list of names, and you're going to say, how many times does each person's name appear in the list? All right? First name is Jane, so you write down Jane, tick. Second name is Mary, Mary, tick. Third name is Jane again, so you just go back and add another tick to Jane. Every time you see a key that you haven't seen before, you put it over here in your list. You make it a key in the dictionary. All right? If you have seen it before, you just add 1 to its count. All right? This will give you the right answer. So, how do I add 1 to the count? Well, what I want is the existing count plus 1. Right? And where do I store that? Well, I store it back under the same key. Right? If this is the second time I've seen the letter T, I want to get the count of how many times I've seen it before, add 1, and save that as the new value for count of letter T. Everybody okay with that? How do I see how many times names have appeared on the list? Well, human beings would just put one more tick beside the name. What you really mean is take the old number of ticks and add one more tick and write that back down on the page, but that would involve a lot of pencil eraser work. We don't do it that way. Okay? So let's see if this does the right thing. I don't know what the right thing is. This is too complicated, so I'm going to do that. The right answer is A appears once, G appears once, T appears twice. Everybody okay with that? Let's see if I get that answer. A appears once, T appears twice, G appears once. It's not the order I'm expecting them in, but it's the right values. Okay, let's come back and do a slightly more complicated test. GAT-TAC. 2 T's, 2 A's, a G, and a C. 2 A's, 2 T's, a G, and a C. Yep. Again, the order is coming out slightly skewed, but I've got the right answer. Okay? Let's try this one. 5 A's, 4 C's, 4 T's, 4 G's, 4 D's. Let's see the number of D's. 1, 2, 3, 4. Yep. Okay. This appears to be doing the right thing. So let's go through it again. What's the question?
There's only 4 keys in DNA.
Yeah. Right. There's my string. First time through the loop. That's empty. So I say, is the letter G, that's the current value of base, because that's what I'm looping with, is that a key in count? No. Count is empty. There's nothing in it. So I come down to the else and I say count of letter G is assigned 1. Count of letter A is assigned 1. Count of letter T is assigned 1. Count of the next T. T is already a key in that structure, so get the 1, add 1 to get 2, and save it back into the structure. Come around again. A is already there, so fetch the old count, which was 1, add 1 to get 2, stuff it back in, and around we go. Okay? A lot of programming problems become a lot simpler using dictionaries.